record it. Hopefully it'll sound a little bit better, but I'll start recording now and at least make this available to you. And I'll try to find some time to go back and rediscuss some of this in post. Okay. I forget to hit that record button so often. Okay. It would be nice if it was over on the other side of the screen where you guys are at and I would see it. Because right now I've got that section of the screen way off, so I can work on this and still see your comments. Okay, so anyhow, so if our frequency is high, okay, meaning much higher than the resonant, okay, then X of C, which is 1 over this 2 times pi times F times C, right, becomes very small. Okay, where X of L is really big. Okay, and so now at these high frequencies, then our current tanks down through the capacitor. Okay, so it's tanking through the capacitor. It's not getting, again, it's still not getting over here to our load, to our speaker or whatever. Okay, it's bypassing all that and going through here. Okay, and so we prevent it from getting to the load. So this is this is our parallel filter. Okay, so the parallel filter will prevent the current from getting to the resistor. Right? It doesn't get to our load resistor. Okay, if it's not within the bandwidth. Okay, if it's within the bandwidth, then this circuit is very, very large. The CL circuit, right? The CL circuit here is very large near that resonant frequency. But if we're very small, if the frequency is below, well below the resonant, or if it's much higher than that, then the current is going to find a way through one of these, and it's just going to say, hey, remember, current follows the path of least resistance. And so the current, the signal, is going to drop down through one of these two, depending if it's at a high frequency or if it's a low frequency. It's going to drop down through there and not make it past the filter to the load, to our speaker or whatever. All right, so we're basically shorting out those frequencies we don't want. Okay, but again, when you talk about the bandwidth, I'm not going to go through it all again, but the bandwidth and the Q and all of that we talked about for a series circuit, they apply. The equation may get shifted a little bit because of this internal resistance here of the inductor, okay, but but the bandwidth and the Q factor and all that still play a huge role in this. Okay. All right, so I'll try, like I say, I'll try to get some time to go back through and re-record this and hopefully maybe even do a slightly better job when I do that. But is there any questions on this? Okay, really this is filtering. When you look at chapter 22, they call it filters, but they're really talking about how these filters work in chapter 21. The big thing they get to in chapter 22 is looking at things like decibels and also Bode plots, which we'll talk about on Wednesday. Okay, but this honestly, resonance and filtering, it's all about these resonant frequencies, and this half power mark and all that comes into play, because of how, I guess it's really right here, right? Because you have X of C equal to X of L at some given frequency. Okay. And so remember, for the parallel circuit, an ideal parallel circuit, the resonant frequency is exactly the same as with the inductor. But for a non-ideal, you have to worry about the resistance inside of the inductor itself, and you get this kind of shifted. So your frequency shifts on you. You can still find that parallel resonant frequency, but it shifted on you because of that R piece in there. Okay. So, there is definitely still a resonant frequency. It doesn't go away. It just shifts over a little bit. Okay. Actually, it shifts lower. So if you looked at that plot up here, right? So the true parallel frequency is shifted back lower, slightly lower, because it's reduced. So this right here is what they call it's actually like the maximum value here. Okay, but it's the true parallel frequency is just shifted due to this resistive piece here. Okay. All right, so notice that the impedance for a series circuit, the minimum occurs at that resonant frequency, but for a parallel, you get a maximum impedance at resonance. Okay, so again, I mean, we've seen this, right, all through even DC circuits, with series and parallel, they flip, right? So if you've got a series resonant circuit, it's going to be at minimum impedance. And if you have a parallel resonant circuit, it's going to have a maximum impedance at that frequency, or shifted a little bit due to the resistance. But all right, so but like I say, really these are the filters. Okay, and then when we get into chapter 22, when we get into chapter 22, we're actually going to discuss these. What we've basically talked about today are band pass filters. Okay, and so what we're doing is, if our frequency is at this within the resonant frequency, or at least within that bandwidth, then we're going to pass that band of frequencies. Okay, so what we talked about today are band pass filters. We're passing the frequencies within this range, okay, within whatever our bandwidth range was. Okay, so if this was our bandwidth, right, these frequencies within this blue ellipse, those are what we're passing. And the things outside of there, we're not passing, we're blocking, we're letting they're not making it through the filter because they're shorting out. Right, they're shorting out either through the capacitor if they're high frequencies, or through the inductor if they're low frequencies, but they're not getting to our load. Okay, so those are what we call bandpass filters. So we will discuss also high pass and low pass filters a little bit on in chapter 22. So we'll talk about high pass filters, low pass filters, a little bit about the bandwidth, but we've pretty much already discussed those. And then we'll talk about the also a notch filter, which is kind of like the bandpass flipped. And then we'll talk about decibels. What are decibels? I'm sure you've heard the term decibels. We'll talk about those, and then we will talk about Bode plots, which is just this is sort of almost like a Bode plot here. These plots showing the impedance and stuff. Only we look at the voltage basically. And but we also look at the phase shifts, which was in that other graph that I showed you earlier also. So we'll just kind of talk about plotting them. And we'll probably talk about something you may have not talked about, which is log plots or semi-log plots. So we'll go over that on Wednesday. And then, like I say, we'll kind of do a lab on this and using the multisim online. So if you have not got multisim installed,